All right, so what if I gave you this? And I said, give me the equation of one of the vertical asymptotes. Now, a lot of people want to graph this thing, which is fine, I guess. I'm just not going to give you a piece of graph paper, or I'm not going to give you a graph of it. But I'm going to ask you where one of the asymptotes are. So tell me what your thinking would be. Find the phase shift. Then add a what? Visualize it. Here's tangent, or cotangent for that matter. You'd have some ladder, right? And the phase shift is where on tangent. So if your phase shift is right here, and I wanted an asymptote, what would you have to add to get to an asymptote? A half of a period? Well, we're going to talk about that next, and that'll pop up. So right there, that would be adding a half of a period or subtracting a half a period, right? So can you find the phase shift? What is the phase shift here? Do y'all see that it's pi over 6? If I set that equal to 0 and add that and then multiply by a third, I get positive pi over 6. So your phase shift is positive pi over 6. And then I'm going to add or subtract a half a period. So what's the period? 2 pi over 3. So you're going to add half.
Is tangent.
Oh, sorry. Half of a pi over 3. Sorry. Are y'all with me? Or subtract half of a pi over 3. And when you add half of a pi over 3, that gets you to this. And then remember, it's an asymptote. So an equation of the asymptote would be what? Would you just put a number out there for an equation? X equals, because it crosses the x-axis. So whatever that gives you, pi over 6 plus pi over 6 is 2 pi over 6 or pi over 3. So that would be one of them. Or you could go pi over 6 minus the pi over 6, which would be x equals 0. And once you establish a pattern, these asymptotes are going to show up every what? Every pi over 3, it looks like, because I'm just adding a pi over 3, adding that, which makes sense because that's the period at that point. Are y'all seeing that? That's a great test question. The only thing last year I asked that question and never went over it. But you've seen it, so it should not be like a real whoa, tricky question. What about this? Secant. How do you now find one of the equations of the vertical asymptotes? Well, how does secant look? Like, you don't have to graph the whole thing, but you have to have a general idea, right? But what are you building it on?
The sine graph.
Secant. So it's built on the cosine graph, right? So, and how would a cosine graph would be built on this, right? And if it's like, if it was a negative, actually the negative and positive won't come into play here on the graph part. But whether this is a negative, so it would start low, in the middle it would be up high, and then at the quarters it would cross. And what did we say yesterday about the asymptotes? Where did they exist? Where it crossed this big, well, yes, that's what you're going to do, but the asymptotes exist wherever this little cosine curve would have crossed the d value. So right here, there's an asymptote. I just got to find the equation of it, and there's an asymptote. So if you were marking all of this off, what does this represent right here? Or maybe that. That represents your phase shift, right? So if this represents your phase shift, what would I have to do to the phase shift to get to an asymptote? Add a fourth of the whole period. You could also add what? What would this be? Adding 3/4 of the period. You could also, if you think it goes the other way, you could subtract 1/4, because there's another one right here. Or subtract 3/4, because there's another one right here. But if it were me, I would just add 1/4, because that's what I'm doing right there. So I would find the phase shift, which again is pi over 6. And then I would add 1/4 of the period, which is that length. And what's the period on this one? 2 pi over 3. So I'm taking the pi over 6 and I'm adding 2 pi over 12, which is another pi over 6. And pi over 6 plus pi over 6 is? Yes. And then remember, it's an equation of an asymptote or an asymptote, so it's got to be x equals. Not too bad. And if I asked you for another one, how far apart are these asymptotes? That represents half the what? Half the whole period. So if I wanted any other ones, I could just add a half a period, so it would be a half of the 2 pi over 3 from there on out. Just little things I could ask on this test. I mean, I'm going to probably ask you to graph. Last year, I didn't ask you to graph as much because you had, I figured some of you had graphing calculators, you're sitting at home. I mean, so a lot of times I gave you the equations, and the graphs like we're going to do today, and said find the equations. Or I asked you questions like maybe like this that you had to think through. But this year you're all going to be in here, so I can ask you those questions. All right? Nobody has any other questions on anything we're doing? Because I won't see you again until your test day after today, right? And there might be a review or two. There's a bunch of stuff for you to do Wednesday, and then your test will roll around. All right, let's take a look at today. And we did this last year, so hopefully you'll recognize it and won't have too many issues. But let's take a look. So we're going backwards today. I'm going to give you an equation of a graph. And when you first look at this, I know I said find the equation of the positive cosine. But does this have to be, and a positive cosine starts where? High and ends high. So that could be a positive cosine curve that you could be basing your equation on. Now I could have said negative cosine, and you could have thought about that one. I could have said positive sine, and you could have thought about that, right? Up, down. Or negative sine, and you could have thought about that. So I'm only telling you positive cosine, so your answer will match mine. And it's easier to grade. So I'll probably do that on the test, is ask you for a certain kind, so I don't have to make 4 keys out. One for positive, negative, or cosine, one for positive, negative sine. Not to mention the fact that you could have different phase shifts also. So there's all kinds of answers, even with just positive cosine that you can give me. Now, if you want your answers to match mine on the key, then when you are figuring out the positive cosine, pick the phase shift closest to the y-axis. And if you do that, your answer will match my key. If you don't, there's a chance you're not wrong, you just won't have confirmation that you're right. Like for instance, positive cosine starts high. So like if I pick this phase shift, I would say that phase shift is the closest to here. Now, if you pick this as your positive cosine, you're going to get a different sign on your C value. But everything but the C value will be the same. The A value, the D value, and the B value, because the period's not changing, right? 4 ticks, 4 ticks, 4 ticks, 4 ticks. No matter what you do, it's 4 ticks. The D value is not changing. The up and down 3 is not changing. But the phase shift could, and the phase shift would be affected by that C. So what I'll probably do on your test is ask you a question like this, and you'll see y equals a box for the D value, positive cosine, so I'll probably put the plus in there. I'll put a box for the A value, I'll write the word cosine, and then you'll have a box for your B, there'll be an X, something for your plus or minus, and then C. So in the past I've done something like that, and you just fill it all in. So what do you see off the top of your head that you could fill in pretty quickly? The D value? So the d value of 1, and by the way, positive cosine, what I normally do on these is I go find the positive cosine. So I'm going to find the positive cosine. It looks like it's right here. And I'm going to put the box around there, and that helps me think. And if I can do that, I'm going to do it. Y'all with me? Yes? No? So the d value is 1. And what's your a value? I always get somebody putting 6 in there, but it's up 3, down 3. I told you it was positive cosine, so you didn't have to think about that part. And then what next? I got 2 options. One, if you think about how we graphed stuff, we were always taking bx plus c, or I'm sorry, the formula is bx minus c, and setting it equal to 0. And for the period, we were taking 2 pi over b and finding the period from it. Now, in your opinion, what would be the easiest thing to find right here? Or easiest thing to use first? Try to figure out what b and c are from this, or try to figure out what b is from this, because the only thing I have left is the b and the c and the sign. Yeah, I think this would be a better idea because I don't know either of those. But of the period and the b, I do know the period. The period is what here? 4 ticks. And what does 4 ticks represent? Pi. So that to me is the easiest thing to use. So again, because this is 4 ticks, and then on this ruler, 4 ticks represents a pi. So I'm going to replace the period with a pi. And then I can cross multiply and solve, and I get a b equals 2. So I'm going to do that first. I'm going to plug my b in. And now that I know b, I can come up here and plug it in right there. Now when you're looking at this, if you're going, but what's x? Well, think about it. What was x when you were graphing these? You were taking bx minus c and solving for x. And what was x? The phase shift. Do you know the phase shift? Because if you do, you can plug it in for x. So what's your phase shift here? You could use this one. You can use that one. It's technically the beginning of another period. You could use that one over there. I pick one of these that's closest, whatever's closest to the y-axis. In this case, it's a tie. So if you used that one, what is that value right there? Negative pi over 2. You could use positive pi over 2. I'm not going to give you one where if your signs are wrong, you'd be right either way. But this one, yeah, if you put positive pi over 2 or negative pi over 2, you'd be fine. But let's just say I use that. If I call that my phase shift, and that is at negative pi, negative half of a pi, I just come up here and for x, x is the phase shift. Because that's what you were doing before, right? You solved for x, and x was the phase shift. So I'm going to plug in negative pi over 2 in here, and then when I move the c over, I get negative pi. Now what you got to remember is this. You don't put minus right here and pi. Because remember the formula is bx what? Minus c. So if the formula is bx minus c, you're going to go minus the negative pi, and it ends up being plus pi. Now in this case, you would have gotten lucky either way. And hopefully that will make sense, because think about it. Do you remember our shifts? If I'm adding something here, then I should be shifting to the left. And I was. So whatever value this has, the sign should be switched there. Because my general formula is always bx minus c when you're doing these.
Could you put, like, instead of doing the first, could you do minus a negative?
Sure. I mean, I'd rather it be simplified, but yeah, if you wrote minus negative pi, that's fine. Are y'all with me? Not too bad? All right, let's try another one. What if it's a positive sine curve? Where do you see a positive sine curve if you were going to box it up? Here? Would that be your phase shift? Here. what would this be? Negative sine curve. What about here? That would be the beginning of a negative cosine. What about here? Now that could be a positive sine curve, totally, right here. But if you want your key to match, this could also be the beginning of a positive sine, right? And I'm going to base my key on the one that's closest to the y-axis. So if you were on your test, if you were to use this, that's totally fine. The only thing that will be different is your possibly the plus or the minus between the bx minus c and the c value. Everything else should be the same. And if it's right, it's right. I usually on my keys on my tests, I write every value that shows up here. And don't be, there's always some guy in the class who's like, oh, I'm going to find a phase shift that's like a mile that way just to screw with Mr. Hurry. Please. If you're wrong, I'm going to be happy. I'm going to put a big smiley face. It's like, ah. All right? So preferably, give me one that's here. Probably somebody like Gabe. He'll do that. And take the time to do it, you know. Anyway, so right here, if I put a box around the positive sign, it would bump up, bump down, it would end here. And from this, again, you would probably be given y equals box positive a sine of box x plus or minus, you figure it out, ending box. So any quick things you can fill in? -2. 4. Let me caution you also, every now and then, these aren't numbered by ones. It might go 3, 6, 9, 12. So be careful on that. If this is numbered by 3s, that's not 4, right? It'd be 12, up, 12 down. So just be careful. I'm not going to intentionally do that, but I'm just saying sometimes. And then what next? You mentioned before that it might be better to start with the period equation. So what is the length? And the period we know is 2 pi over b. And we can find the period, and here it looks like 4 ticks again. But this time, what is 4 ticks? It's 2/3 of a pi, right? Because it's 4 of the 6 ticks. It's 4/6 of pi, or 2/3 of pi, or 2 pi over 3. Are y'all with me on that? So the length of my period is 2 pi over 3. I'm going to replace that with 2 pi over 3. And if 2 pi over 3 equals 2 pi over b, then it's pretty easy to see the b is 3 when you cross multiply by, or just eyeball. Great. And now that I have my b value, I can take that and plug it into that formula that I used to find phase shift. Except when I plug the b in there, I can plug the phase shift in there. So I get 3 times the phase shift. I can subtract c or add c to the other side. And what is my phase shift here? And this is where you could use one of either one here, which will make everything the same, but this and this might be different. So what if you use that? What is this value for phase shift? That's right, negative pi over 6, because it's 1/6 to the left, so negative pi over 6. So if I chose to use negative pi over 6, then my c value would be negative 3 pi over 6 or negative pi over 2. So I would go minus a negative, changes it to plus, pi over 2. Y'all see that? Now, what if you used this one? What does that represent? That's 3/6 of the way to pi, so that's a positive pi over 2. Well, if I used a positive pi over 2 in here, that leaves me with a positive 3 pi over 2. And I would come up here and say, oh, well, my formula is 3x minus a positive 3 pi over 2. So you might have that, or you might have that, because this one's minus a negative. Doesn't matter to me. Y'all with me? Now they start to get a little more tricky now. But sometimes this first one you're going to see it's not that bad. All right, check out tangent. Now the only thing about tangent that makes it a little trickier is it's not quite as obvious what your D value is. Because it's hard to just kind of eyeball this and go, hey, where is the middle? Is it here? Is it here? Is it here? I mean, where is it? So it might be a good idea to kind of figure out where your asymptotes are, because we do know this. If I know my asymptotes, right, what has to happen on this D value? It has to be dead in the middle, right? Whether it's tangent or whether it's cotangent. So if I know where my asymptotes are, like hypothetically, what if I came in and said, all right, I think this is my asymptote. Right there. Hypothetically. Well, if it was, then what would be dead in the middle? 1, 2, 3, 4, 5, 6. I would think maybe that's dead in the middle. But here's the problem with that. What has to happen? This is a negative tangent, does it? Halfway between this and this, don't I go up to my A? And then halfway between this and this, I go down to my A? Isn't that what's supposed to happen? And isn't that amount supposed to be the same? Well, let's check this. Halfway between this and this, it looks like I'm going up 1.75. Halfway between this and this, it looks like I'm going down 5. This is not right. Now I'm going to give you a little help. I'm not going to put asymptotes in between grid lines. So you really don't even have many options here, do you? There's only one grid line in between here and here, and it's right there. So let's move it. So now sometimes there might be more than one grid line, and sometimes the number of grid lines might be even, which means I've made the graph skewed a little bit and make you have to check these things. But check this out. Here, there's only one grid line right there, one vertical line. So if those were my asymptotes, what would be the dead middle right here? What line? What line? Y equals 1. See that? Right here, that's the only line that would put that point right in between. And then to check and make sure, because the other one looked pretty good too that I graphed, if I go halfway in between there, I'm going down 2. Halfway in between here, I'm going up 2. I feel pretty good about where that is. Y'all seen that? So it requires a little bit of checking, and when I do the next one, the cotangent, you'll see where I think this next one is a little dirtier. Yes, it is a little dirtier. So let's figure it out. Negative tangent. So talk to me. 1, but a lot harder to get that than it was with sine and cosine. You had to do a little bit of work, a little bit of guessing and checking. This. A lot of people miss that value because they forget. They get this right, but they forget to go and check that to see if it's right. 2, right? That's where your A value would have been. Halfway up 2, halfway down 2. And then what did we say would probably be the best thing to find first? That the period no longer is 2 pi over b, it is pi over the b value. And what's the length of the period here? Looks to me like it is 1, 2, 3, 4, 5, 6 ticks. How big is 6 ticks? Pi. So I'm going to replace that with pi. And if pi is pi over b, cross multiply, solve whatever, b is 1. And then there's where people miss a lot. They get down here to bx minus c, and they plug the b in, they plug the phase shift in. Where's the phase shift? In the middle of the period. And that's what people probably miss the most on this. The middle of the period. It's the only one that works this way. You can use this phase shift right here. You could use this phase shift right here. If you want your answer to match mine, you probably want to use this one because that's the phase shift that's closest to the y-axis. I believe I did that on all of them, just to give you a little advantage. What is that value right here? What is that? Pi over 3, because it's 2/6 of the way to pi, or pi over 3. Plug in your pi over 3, plug in your b, move the c over, there's your c value. And because it's positive here, that negative is going to remain. Not too bad. If I'm boring you, great. Let's see how you will do on this one. Positive cotangent. I'll probably give you one like this. It's a little trickier. Maybe. You might not think it's tricky at all. So you know the vertical asymptote's got to be on the grid line, but you're looking here and you're like, wait, that's in between there. But so is that in between there. Which one is it? Now I have people every year that make little estimations. They do stuff like, well, this one is further from that. It's kind of like more in between them. So they go with this one. But here's the thing. I can change this window. It's your viewing window. I just went from -6 to 5 on the Y, but I can change the viewing window so that's not the case. So don't go based on just what you view. Picture time.
Yeah.
All right, so we were talking about how, what do you do when you're not sure which vertical asymptote to grab? What's the worst thing that can happen? Try it out. Guess wrong. So I'm going to intentionally guess wrong. Think this. So what if I pick that asymptote that's just to the right of that? Then I would pick this one just to the right of that, and then this one just to the right of that. So let's just say I picked that. Now, I may be right. I don't know. I'm just guessing. So if I was, then think about your ladder, right? That D value, you have to be right there in the center of it. So if this is 1, 2, 3, 4, 5, 6, 7, 8, it should be right there at 4. You with me? Now, to me, that doesn't look like it's right on a tick mark, does it? Or does it to you? Now, I can make these, I can tweak them and make them look that way. So don't just get sucked in and go, oh yeah, it looks pretty close, that must be the D value. It may be, but what's the next check? Go halfway each way and check the A values. They have to match. So if I went 2 there, 1, 2, 3, 4, 5-ish. If I go 2 there, 1, 2-ish. That is not the right D value, and that means those are not the right asymptotes. Are y'all seeing that? So that, just try the other one. More than likely, there's not more than a couple in between there. So if this was it, then 1, 2, 3, 4 would be the middle. That would be it. And then halfway, 1, 2, 3. Halfway, 1, 2, 3. So that checks out. You need to run those checks, or you're either going to be just hoping to be lucky. So now that I know this, I know what is this? -2. What is this? 3. And then you're back to doing the same thing as before. The period is 1, 2, 3, 4, 5, 6, 7, 8 ticks. What is 8 ticks on this graph? 2 pi. So if your period, again, on cotangent is pi over b, and your period is 2 pi, and this is the first time it's probably not completely obvious, if I cross multiplied, I get b times 2 pi equals pi, and if I divide by the 2 pi, I get 1/2. So my B value is 1/2. And then once I know the B value, I can take it and plug it in. I can take it, plug it in there. I can plug my phase shift in for my X and solve that equation. So 1/2 here, move the C over. And what is the phase shift on this? Man, if I can go with 0, I'm going with 0. And remember, it's cotangent, so the phase shift's not the middle, right? It's at either one of these. So you can use 0, you can use 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. That wasn't right, was it? It was from the other one. So you could use 0 as a phase shift, 2 pi as a phase shift, negative 2 pi, but man, if I can use 0, why not? Because if 0 is your phase shift, your C value is always 0. Just makes your life a little easier. And then it doesn't matter whether it's plus or minus. Not too bad? All right. We'll do one of these, 5 or 6. Pick it. Yeah.
So tangent and cotangent, the period is pi over b, and the rest of them are 2 pi over b?
Correct.
Okay.
So pick one of these, cosecant or secant.
If I look right.
Sorry?
Back up.
Oh,
Why, well, just the one you said, why wasn't that phase shift? I thought,
in the hat in the middle?
yeah,
Only for tangent.
okay.
Tangent is the only one that has a phase shift in the middle. On all the others, phase shift is either the beginning or the ending of the period.
So cotangent is just the beginning.
Correct. Yeah. All right, so let's just try this cosecant. So negative cosecant, so negative cosecant bx something something. Now what is a negative cosecant built from? A negative sine curve. So you need to envision a negative sine curve's box in here. Okay? Now, if you think about what you did, let's work backwards. When you were sketching these, you were starting at what part of the curve? Think about how you did these. You graphed the sine of the cosine curve, and then from the tops, you went up, the bottoms, you went down, right? And the vertical asymptotes were right there on the D values. So if you think about that, you know there's a vertical asymptote here. You know there's one here. Now that may or may not be your box. Don't think that that's the edge of the box. The D value runs right through the middle. The amplitude was right there under each of the little parabola looking things. And then if you were sketching the curve in here, the curve would be starting here, not this necessarily, but whatever. It'd be going through there, 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 there. Y'all see what I'm doing? I'm basically marking the highs and the lows and then just visualizing a line right there because the points are all 1/4 away apart from each other when you consider the box. Are y'all seeing what I'm doing? Nice even zigzags. So this curve, whether it was cosine or sine, would have looked something like this. And I need to get this in there so that now I can go and identify what a negative sine curve would have looked like. I've got to be able to put a box around it because the box is going to help me with my phase shift. So where would you put the box? Would you put it here? Start the box there? If I start it there, what am I going to have? A negative cosine? What about if I start it there? What am I going to have? Positive sine? What if I start it there? Positive cosine? So if I want a negative sine, I need to start it there for a bump down, bump up, that, or maybe there for a bump down, bump up. And I said I'd probably pick the phase shift closest to the y-axis, so I'm going to choose this as my phase shift, and I'm going to make my box that. And it's important that you do this because you've got to be able to find the right D value, A value, and length of the period. But if you picked a different box, if you picked that one as your phase shift, that's totally fine. So from this, what can I determine? What's this? Three. What's this? 2. What are you going to do next? Find the B using the period. So if the period is, and I'm back now to, period is what? Well, yeah, but what's period equal to? 2 pi over b. Only the tangent and the cotangent have pi over b. And yes, the period is 6 ticks. And what does 6 ticks represent? 6 pi. Y'all see that? 1 tick is pi, so 6 ticks must be 6 pi. So if that's a 6 pi, and that's equal to 2 pi over b, and I cross multiply and divide by 6 pi, I get what? 1/3. And if b is 1/3, I can plug it in there. My phase shift I can plug in there for x. And by the way, what would you use as your phase shift? That would be 2 pi if you use it. If you use this as a phase shift, you have -4 pi. But I'm going to use 2 pi, so I'm going to plug in 1/3 here, plug in 2 pi for my x. I'm going to move the c over, and there's my positive 2 pi over 3. So when I plug it back in there, I'm going to subtract a positive 2 pi over 3. I hope this feels like you're doing the same thing over and over again. But you've got to know the differences between the cotangent and the tangent than the rest of these, and kind of a way to work backwards on these to be able to get what you need. And I usually, honestly, I just, for each value right there, it's a 1/4 point. So if you miss one, ... The unfortunate thing is if you miss this value, then when you plug it in here, you're going to also miss that value. Because that's, I'm just grading a quarter. It's like kind of almost like a multiple choice. So miss that, miss that, miss that, miss that 1/4. Sometimes if you do all the math right, you miss this sign as well. It's like a 1/2 point or something. All right? Okay, since I won't see you, all I wanted to do today was to finish up and maybe start your review. The review's 6 pages, so it's a little on the long side. So if I were you, I'd kind of get started today, work on it tomorrow. Tomorrow we do not have a meet. If you have a question, you got to go sign up on that sheet or whatever and pick a time, and I'll just whatever, jump in the meet or whatever time is that you're signed up for. I think last week I had one person signed up, and she signed up during the testing time, and she was testing. So go figure. Had a very free morning, but you're welcome to log in or whatever and ask questions if you need them. Or if it's easier, sometimes it's easier to say, hey, how do you do so-and-so, so-and-so? And if I can just type out an answer, I'll send it back to you. If not, it's no effort to talk my way through the problem with you and then just send you a link. Really, that VidGrid thing works really well. It's very easy to do that if you have questions. Just don't give me the question, Thursday night right before your test is Friday. Yeah, Thursday night right before your test. I might or might not be able to get it done when I run in here on Friday morning. Just depends on who's interacting with me or whatever. Yeah.
For number 5, would
Number 5 on what?
that we just did.
Okay.
Would the sign that goes with that, would that look the exact same with the, would that, what would the sign graph look like? Would they look similar?
You mean if I was asking you to graph oh no, the sine graph, the negative sine curve would look like this. Oh, sorry.
The equation I'm getting.
Yes, if I had said graph a negative sine curve, it would look exactly the same because I based all of this on the negative sine curve. And if you think about it, that's what you did to graph a negative CSC, right? You literally graphed the negative sine curve and then peeled those layers off of it. Right? So going backwards, you're gonna basically find the negative sine curve and replace that with the cosecant. Or a negative cosecant. So that's the only real difference, but you can think through the other graph, which you're probably more comfortable with. I tell you what, we got a couple minutes. I want to go back and really review. How about this? In the next 3 minutes, what if I give you sine of theta equals negative square root of 3 over 2 versus sine of theta equals negative square root of 3 over 2 from negative 250 to 250, or inverse sine of negative square root of 3 over 2. What is this looking for? In your own words. Yeah, I'm looking for the angles that make that true. Is there any limit to the angles that can be true on this sine curve? No limit. So when you go to solve this, your thinking will probably be at what angles does the sine value go down a lot? Down a lot would be over a little, down a lot. So at those two angles, which would be what, 240, 300. Now we can't just say theta equals 240 and theta equals 300 because there's an infinite number of angles that can land in those spots, right? Every 360 degrees plus 360n. Now, what's different about this? It has a limit. I still find these, right? So I'm still going to find these, but then I'm going to use them to answer that question. Does 240 work? Sure. Does 240 plus 360? No. Does 240 minus 360? Yes. That's it. Does 300 work? No. Does 300 minus 360? Yes. Does that minus another 360? No. What's the difference then here? This has a built-in limit of what? Negative 90 to 90. So even though you don't see that, it's built in. You're still thinking the same way, right? But here's negative 90 to 90. So clearly that's out. But is 300 between negative 90 and 90? Are there any angles from this that could be between negative 90 and 90? Yes. I could subtract the 360 and call that negative 60. And by the way, if you wanted to use negative 60 here, you could. It's the same thing. And it's still out of 360, you still get the 300. But here, you have to use the values that fit. Here, you have to use the value that fits. But here, there's an infinite number of answers that could work, because there's no limit on anything. Yeah?
What will and won't we be able to use a calculator on?
You're going to use your calculator to solve stuff like sine of 2.543 radians, or tangent of 36.25 degrees, or solving equations like sine of 3 theta equals negative 0.4165. Problems where you don't recognize unit circle values. And you'll have a page that some will have calculator stuff, and then you'll have the rest of it won't. And I'm trying to think, I made it a couple weeks ago, or a week and a half ago. It might be where I hand you one, you do the calculator work, give it back to me, and then grab the other part. But I have to go back and look. Because I've made so many tests, and I'm trying to stay a couple weeks out. Yeah?
What's the difference between the first two? Why does one have a limit and one doesn't?
Just because I decided. So like, if somebody says to solve, and there's no limit given, and you have to solve for every possible angle and
So that's just what you wrote above on the second one?
yeah, this is just me saying, oh, I've just randomly decided to give you a limit.
Okay.
But on the inverse trig functions, there's a built-in limit. It's never randomly decided. It's always negative 90, 90 for sine and tangent, and 0 to 180 for cosine.